Hello everyone and welcome back to part 2 of the MMO development class meeting number 7. And at this point I'm going to turn it over to Lee, Nelson, and anyone else that would like to get involved in the IRC. And if you have some really strong input that you would like to give after hearing both Lee and Nelson discuss this, and you'd like to have me bring you into the conversation through voice as well, then please let me know, and we'll do that. Because we are now getting to a point with the sculpting system wrapping up, and again, basic sculpting system, but still one that offers a lot of flexibility, which is Lee, you've done a beautiful job. Been very, very happy with it. The thing that I wanted to move on to next is obviously going to be persistence, because right now if you're standing on a patch and you paint something out, it's like, oh, look at my beautiful masterpiece, and then you turn around and you're running off and that patch gets removed, and then you turn around and you start running back and the patch gets added back in, your stuff's gone.
Different patch.
So we need to make our changes stick. Persistence. It's very important here. Tragic. Justin, you're absolutely right. It was tragic the first time that happened. I was like, oh, man, I forgot. And for those of you that are watching the most recent videos, you know just how much I love sculpting. And I'm not saying that sarcastically. I really do have a blast with the sculpting. It's so much fun.
Really? Even I thought you were being sarcastic there for a minute.
No. And then when I run away and come back and it's all gone, I'm heartbroken.
Yeah.
Or every time that Lee's like, all right, hit stop so we can make a change. But I want to keep what I've done. It's cool. So anyways, Lee, start talking about some of the things that we've been discussing over the last few days.
About persistence?
Yeah.
All right, where's going to be the easiest way to start? Let's probably start with discussing what we need to do to make our world persistent. Obviously, we need to save the data of the world. The data that we need to save is going to be mostly, or primarily, if you looked at just the way terrain patches are right now, is the heights that are at each of the positions for each vertice. I had to think of which word to use for each of the vertices in the world. Now, in most games, this isn't too bad of a problem because they're broken up into individual zones, areas, whatever you have, and they're static. So once the artist creates the world, they get saved off and they're cached and they don't change. Our world's a little bit different. One of the things that Jason wants to have is the ability to have multiple artists go in, work on the world in real time, while other people could technically be running around in this world at the same time. Now, not only is this something that we're looking at the potential of doing
We're going to do it.
Development, we're going to do it with the game.
We're going to do it. No, we're going to do it.
So we're talking having a world that can be edited by multiple people at pre-launch and after launch. So that gets into some interesting problems. Even more interesting is the scale of this world. We're not talking a little world. We're not talking little zones. We're not talking about breaking things up. We're talking about massively, insanely large terrains. The play testing that we've done so far yields a zone of 801 patches wide by 801 patches deep. That works out to roughly about 641,000 different patches. I'm going to round it to 640,000 just to keep the numbers a little bit easier to comprehend.
All right. For all of our serious students out there, and I know that's all of you, get your pen and paper out. Start writing some of this down. Start keeping some notes. This is an interactive class here, ladies and gentlemen. We want to start writing these numbers down so that you can stare at it while Lee's talking, Nelson's talking, and if something suddenly smacks you upside your head and you go, oh, man, then we want to hear from you. And Wedge Bob, no, write it down. The whiteboard's not hooked up at the moment. Sorry, we had no intention of actually doing that. Because Zach's not really been in on any of these particular conversations, so he's going to be kind of hearing it like you guys. Gavin, that's only because everybody over in the UK has blue filters on their screens. It's a whiteboard.
Actually, that's kind of true. If you take a look at a lot of the graphic design which comes out of Europe,
Yeah.
a lot of it's blue tinted.
Yeah, I noticed.
It's just everything's got kind of a cool tone to it.
Yeah. Okay, so you said you're going to round it up or round it to 640.
Run down, yep.
So 640,000 patches.
Yep.
And
in
this is
a zone.
And this is a zone, okay?
Yeah, we're not talking the whole world, at least from all the initial talks, because Alethea is supposed to be pretty big. So there's the potential of tiling zones, like you tile a patch.
Mm-hmm.
So you would go from one zone into the next zone, and all the zones would line up. So how many zones? No idea. That's an open spec. Nobody knows what it's going to be. It may change after the fact. So whatever data system we come up with has to be able to handle a flexible number of patches and a flexible number of zones. Now, multiple zones would make up a single world. There's also the potential of having multiple worlds. So when you look at the numbers, things can get out of hand very quickly. We're going to concentrate on the numbers for a single zone to start off with. Now, if you look at our zone with 640,000 patches, each patch is made up of a grid of vertices. The vertices are on 2-meter spacing currently in the R&D, and I'm using an array of 51 by 51 vertices to make up a patch. That equates to 2,601 vertices. If you do the math, 640,000 times 2,600 or 2,601, you very quickly get a whole lot of vertices. That being
Is
on
that the official
order,
math factor?
That's the kind of math I like. What's the answer? A lot.
If you do the math, you end up with a lot.
Yes.
Excellent.
About a little over 1.6 billion.
That's a lot.
Yeah. Now, my early estimates and putting some padding in each vertice isn't just going to be recording its height. Its height would be a float, so you're talking 4 bytes for just its height. But that is the procedural height that the system generates. That doesn't contain the changes that are made by artists going in and raising and lowering terrain. So now you're talking about a second float that has to keep track of the displacement of the original procedural height. Now, we also want to be able to commit this, so we've got a temporary save of this information, and then it can go through a review process. If we like it, we can commit that patch and it gets baked down, which then means that's the new value for the start of the terrain. But because it's procedural, we'll still have the ability to go back and regenerate a patch to factory default, if you would, and then we could start all over if we need it. So now we're talking about 2 floats just to keep the height information, so 8 bytes of information. Now, the system also has to be able to keep track of splat maps for the textures that are going to be painted on the terrain. We'd like to have splat maps to keep track of, say, what type of grass goes into that area, what type of trees go into that area. So now you've got different splats for the foliage system. Then you need additional splats for keeping track of what type of mobs or NPCs are going to be running around that you can go and kill. So all these different types of splats would be needed to be saved along with the height information, ideally. So I am estimating that for each vertex in the system, a size of 128 bytes of information. So if you take our 1.6 million multiplied by 128, we get roughly 208 gigabytes of information that needs to be stored per zone. Now, as far as I know, There is no game out there that saves this kind of information that can be dynamically changed at any point along the way. So I couldn't really look at the game world for a type of solution. The closest I could find were mega textures and virtual textures, but even those are designed to save image type information, and I think around the largest I've seen was 128K by 128K. Images are really not even getting close to the hundreds of gigabytes that we're looking to handle. So I had to look at the scientific community for their type of solutions. We're talking things like NASA, the National Oceanic, whatever that thing's called, where they keep track of all the salinity and temperatures and currents inside of the world's oceans.
They should change their name to that, seriously.
The whatever, yeah. So,
Yeah,
and
it's NOAA, isn't it?
I don't remember.
Holy. Anyways.
You know how many white papers and documents I've read? My head's mush right now. So, but the file formats that I looked at were things like the CDF format that was developed by NASA for keeping track of their astrological data, HDF, which is another self-describing language.
It's funny.
I looked.
That means by implication you're trying to track the same number of vertices as there are, like, what, stars in the universe?
Yeah, close. So, and then we end up looking. I looked at NetCDF and FITS. FITS is another astrological file format that was designed more around images, but also can save other information. But these are, I think, for the most part, CDF does have a C# implementation. Or a wrapper for it, and then FITS also has one. But the other ones are usually implemented in Java or C++. So that meant getting into managed code, which wasn't looking like a whole lot of fun. And once you start reading their specs, their file formats are so overkill for what we need that I started looking at the possibility of rolling our own just to keep our information in. So we could design it to handle a custom structure for each one of our vertices. Now, where the discussions came in is when I first originally started thinking about the problem of persistence and being able to save all this information, my first instinct was to go to a database, which meant I wanted to dump this on Nelson's lap, go, hey, you're like the king of this stuff with you and, you know, all your fancy RavenDB and MySQL. Hey, you want to handle this? And he's like going, why don't we just do it in files? So he kind of batted it back into my court. And it's going, well, why not databases? Well, they can get kind of slow for the amount of information that we want to look up. And some of the things that we want to look up that databases could handle is it naturally builds indexes to be able to pull the information for a single vertex at a time or a group of vertexes or vertices. And so they also give the nice ability that they're self-optimizing. They have the ability to cache, so the most recent information is accessible quicker. And if we had to roll our own, that would be a lot of code we'd have to figure out ourselves or just skip entirely. When I started doing research on doing file formats like HDF and CDF, found out that you can randomly access, and if you're not compressing your information, you can get the information at any point in the file. So technically we could get the vertex information with, you know, at most a couple of reads, one for an index to get the offset of that record, and then the offset inside of that record would yield the information for that vertex and pull that out. That got us into another round of discussions of most of the large file formats like HDF and CDF all recommend a single large file. So you've got a large file, and some of the formats have a large file with an index file. So you'd have two files. You use the index file to figure out where the records are stored, how big the records are, and if they're compressed, and what kind of compression that they've got, so on and so on. So I was looking at that, and I built some tests to see if I could make a file that was roughly about 208 gigs. And I did, and set it all up with an index file. The index file ended up being right around 80 megs, and the data file came in at right at 200, or it was 180 gigs with compression, came in at about 210 gigs without compression. And I had used RLE, but I took liberties with the RLE because I didn't want to get into different type of compression just yet. But so I had filled in the data structure with 20% of zero value. So I knew that we're going to get at least probably about 20% compression. So we built that and ran it. It took about 3.5 hours to build out that file. Worked well, no explosions, and all was good. Then Jason brought up a nice point, or an interesting point, that we had to look at, and his concern was if we have a single file, what happens if that file becomes corrupted? Because with having a separate index and each thing that is indexed randomly, we're able to go through, and the test had checksums, and we could look at the checksum, find out what records were corrupted, pull those records out, and go back to a backup and rebuild them. But it's a very time-consuming process. So his idea was,
well, real quick, it's very time-consuming, especially if, let's just fast forward and pretend that we are now running a commercial game. Mm-hmm. We're down, correct?
Well, those patches would be down until the system built.
But that means the system is still accessing.
Which got us into our argument was whether or not, what level of file corruption are we talking about? Are we talking about corrupted data inside the file itself? And if that was the case, the file that I had envisioned would be self-repairing or self-maintaining. It would keep running, but the failed records would be offline until they got erased from the internals of the database and appended on, and we would at some point, after we exceeded a level of fragmentation, we would have to take the system down and defrag the large file, which, based off of the initial test, could be a couple of hours. So right. A very, very valid point.
But when you're talking about something like WoW scale, you're going to have multiple computers that are clones of, every single machine serving out data. You should be able to hot swap in a clone if something does go down.
Well, or even more so, you could go, okay, this record is dead. Who's my clone? Go ask him for his copy of the record, verify that, make sure that's valid, and then replace my downed with that one. Or hot swap to the clone and have the clone answer the request.
Yeah, you should do that one, because once you start detecting file corruption, you should evaluate the hard drive to make sure that you're not having anything that would happen again, or the hard drive isn't going out.
Yeah, right. For sure.
Now, yeah, exactly. And the solutions that we're talking about or where we were initially talking about, was if it was just data corruption, not if it was an underlying hardware failure. If it's underlying hardware failure, that's a different issue. So Jason's was leaning towards, and Nelson had brought up, using multiple files. So now we're talking about the potential to have 640,000 individual files if they're self-describing and they have headers that index themselves inside of it. If they have external files, then that number doubles. So we started playing with the OS and trying to figure out what would happen. NTFS has some interesting things with the way it indexes folders with large files, and what I've read, it should be able to handle roughly about 16 billion files in a folder, theoretically. Now, the people who have been working with it say that real number is closer to a couple of million before the indexes get to the point where they're fragmented. They themselves are several gigs in size, and eventually they fail, with the potential of causing corruption to the NTF partition, or the NTFS partition.
Right. And then in addition to that, you also have to realize that At that point, you're counting on the operating system to do the indexing, which you don't have direct control over. And it's kind of determining if the operating system is capable of doing that. But if for some reason it decides not to index something because it's getting high load elsewhere, you might have inconsistent results in how fast you can access data.
Right. And then, so instead of keeping it all into a single file, and if you've ever worked with Windows Explorer with massive amounts of files in a single folder,
Yeah.
you'll find that after about 50,000, things start becoming stable. After about 100,000, you're gambling whether or not you're even going to get Windows Explorer to explode or keep working or just blow up on you. So that wasn't going to be a workable solution. So the next step from there was looking at using a tiered folder structure and using the folder structure itself as indexing so we could drill down to a single file inside of a single folder. So Nelson worked out some tests on that and was able to put that together. And just for experiment, I did do the single file trick, but not in folders. But I was using it with full-size patch data, which was 326K per patch of information is what it initially calculates out to be. So that seems to all work. The folder stuff works quite well, but the concern becomes at this point, if using multiple folders and multiple files, what is going to be the penalty for opening and closing all of these files multiple times? Because with the way the train system is laid out right now, I'm looking at 3 levels of detail. The first level, the highest level, is the high resolution information at a 2 meter a 2 meter resolution. So you'll have one vertex every 2 meters. And we're talking upwards of 9 to 81 of those patches visible at any given time at 2,601 patches or vertices per patch that have to be pulled out. So you're talking about opening up 9 to 81 files and reading in the information. That in itself doesn't seem to be that big of a deal. The level 2 detail is the larger terrain, which is at 100 meter resolution, which goes out to a distance of 15 kilometers in every direction. So it's 30 by 30 kilometers or 900 square kilometers with a vertex positioned at every 100 meter interval, which with the high resolution definition means that we'd have to sample one vertex for every 2 files. So that has 9 levels, which covers 900 different patches, and we'd have to sample every other one, so we'd have to sample about 450 files. Now that gets a little bit more intense and opening and closing files, but that's nothing compared to the tier 3 or the third tier of detail, which is the planet surface itself, which is at about, I think right now, a 200 meter scale, which means it needs to sample once. Okay, sorry, the tier 2 samples once every patch, so you got to open 900 files. The tier 3 opens up every other patch, but it has to open up every second patch for all of the patches, so it has to open up 320,000 patches worth of information or files to get its necessary information to build the vertex data to get that patch in place, which would all end up getting read into the vertex cache, at which point it could be used later. Now the concern was, once we've doing 320,000 file opens and close, plus another 900 for the tier 1 or tier 2, and then up to 81 reads, how much performance are we losing with all the opening and closing? And then we have to decide, is that going to slow us down? If it was only reading that out and reading in the whole patch, that is one thing. But because the system for the vertex cache could potentially request single a single vertex at a time, over and over and over again, then and we're possibly reading in tens, hundreds, thousands of these in a second. And if they're bouncing all over and not caching out the patch to make sure that it's loading all the vertices that it needs from a patch at a time, we've got the potential of wasting a lot of time opening up all these different files. So that
Sure.
leads, would it be faster to do a database at that point, or would it now be worth the risk of using a single large file, which we can open up a single time, leave open for the duration of the game, and then randomly read and write to that as needed? So,
Right, and I mean, still, I'm starting to lean towards a single file approach. I mean, it's
Yeah.
not sounding as feasible as the multiple files, but we did discuss a solution where we replicated some of the data into patch files, or perhaps different patch files, or a different coordinate system per tier, to where we could reduce the amount of writes, which of course, or the reads. It would increase the amount of writes, but decrease the amount of reads. So, I mean, there is a solution to opening up billions of files every request, but it's still going to be a lot of files, and that's going to be added complexity.
Correct.
right, we started talking about almost like virtual mip mapping of the vertex data itself, where we would end up building out ahead of time the data from the high resolution data. We would use that to sample in our level 2 information, save that out separately, and then take the high res and sample it out at an even lower resolution to build the third level of detail, cache all that out. The problem that I can see happening with that is now every time an artist goes in and painting and is adjusting stuff, we have to do the 3 different calculations to make sure that the information goes into the right or each of the level of details correctly for each one of those. So,
Sure. It multiplies every write by 3.
Yep. So it's just another level that we're looking at. But then we get into the data format itself and making sure there are a couple of things that we'd like to do. The fact that the data format, whether or not it's a single file format or a multi-file format, we'd like to be able to define the size of information, meaning we'd like to be able to save a record as a single dimension array, a 2, 3, or 4 dimensional array, and define it by bytes. So we're defining the record as up to 3 dimensions, but the 4th dimension is literally the number of bytes that are used in each entry of that 3 dimensions. So if you look at a 3-dimensional, like a Rubik's Cube, where each one of those little cubes would represent a storage location, the 4th dimension of the storage system would dictate how many bytes are saved in each one of those cells. So if we do it that way, then we can define each different record to save maybe a single byte. It could save 4 bytes for a float or an integer. We could save 64 bytes if we needed a long or a double. So it gives us a system where it's not a fixed format data system, and then each file has the ability of describing where the record starts, how long that record is, and defines a checksum for that record so we can validate if it's still good or not. And we also need to be able to individually compress a record if desired. Now, if it's something that we need to access randomly, then we can't compress that record, obviously, unless we want to read in the whole record, decompress it in memory, and then read it, and then dump the information. But that slows down the whole process. But in the case of some things like mip maps, where we may not need to load those in a vertex at a time, but we could load that in for a patch at a time, then some of the compression that I was looking at is switching over from RLE to using DXT1 or DXT5 compression, which is a compression that video cards like to deal with because they can be decompressed in real time very easily. So because the splat maps would end up going in well, particularly the splat maps for the texturing of the terrain could then be cached out to the file, saved as a DXT1 or a DXT5 compressed format, read back in, and then sent directly to the video card, where the video card could then use that information to texture the terrain, all inside of the shader.
Hey, Lee,
Yeah.
at this point, I was just going to say, why don't you take a look over at the IRC?
Okay.
And with what you've explained so far, there's a few questions that have popped up over there. See if you can answer them just to help them get a better idea of what's going on in your head.
Okay, no problem. Sorry, I kind of ranted.
No. You were having to get all that stuff out.
So how far back do we go?
But I do. Once you're
not
done with
far.
those, I do have comments about what you were just saying.
All right, so we're professional. Okay, Chipsius, Lee, are you going to add copy paste train functions? I wasn't really thinking about copy and paste. What I was thinking about was having a kind of like an undo brush. So because I was thinking about having the two different heights, the original height or the last baked out height, and then the current modifications. So you could very easily make a brush that compared those two heights, and you could erase away some of the modifications. So that would roll you back to the last committed state, and then have another brush that would take the last committed state and blend that all the way back down to the procedural state. So as A. Enrico said, yeah, kind of like a revert brush. So we could undo things instead of a copy and paste. Now, it would be kind of, well, let's see, let me think about it. Yeah, you could make a copy and paste function fairly easy with this system, because all we're doing is copying new height information. And with the ability to revert back to the procedural, we could easily do that. But the way I was thinking is, the system that you guys have right now in the R&D for generating out the terrain is a temporary system that's kind of a lower end system to give us something nice to look at. For the full-blown game, I would envision a more robust system that would build out all of the terrain and bake it into this data system and then read from there. And that gets into the interest management and going back and forth between the server and client. But that'll be stuff that we cover later. All right, so let's see, what else we got? And let's see, that's all. It's blue. And splat mouse. So that was splat was the sound that when you get stepped on by a giant. Yeah, that too. 208 gigs. That's the size of an SSD. Yeah, that's just the size of a single zone. You guys can talk while I try to find some more stuff. Let's see.
And
Well, I didn't want to start talking and then you.
yeah, and then you jump in and answer
Yeah,
a
I
question.
can see
I will throw this out real quick. Hey, Enrico just asked what a zone is. What are you defining as a zone?
A zone is just kind of like a logical grouping of patches. I'm thinking zone almost in terms of a WoW sense, where a zone is an area that is consistent within itself that you can travel without having to have some sort of loading screen, some way of transitioning from one area to the other, whether it's kind of like a portal technique or kind of like you do when you transition into a city from an outdoor area where you've got that little maze, so you turn a corner and you can't see what's going on behind that corner. Some way of hiding the fact that you're transitioning from one area to the other. So a zone is defined as the largest area that we could possibly get away with inside of Unity before we have to reset everything because we've gotten so far from the center of the world where animation and our level of precision starts falling apart.
Right.
So
Let's go ahead
that's
and
what we're
jump
calling
back
zone.
up just a little. I don't want to answer the questions that coming in at the bottom because the ones that came in earlier then are just scrolling further and further away. So you guys keep throwing them in. We'll get down to them. But I know there was one up there. Let's see. About if you have 3 levels of detail, why don't you use 3 different file branches for each level of detail?
That was one of the things that we're talking about. If we did use multiple file systems, then yeah, we would have different files for each one of it. We also talked about the possibility of containing each of the 3 levels of detail inside of a single file, because when you look at it, the information is the same for each vertex. It's just how much information is each side. With the data format being able to accommodate any size of an array of bytes, we could easily put it all in the same file, or we could put it in separate files. That's no big deal. So as the trick with it is, we do have to make sure that the data and the client are on the same page, because what we're currently envisioning is that the whole world only exists on the servers at the start of the game. You're given a client that knows nothing of the world. So as you start up, you pick, your class, race, whatever we end up calling it, and you pick your starting area. And as you go into the initial area of the world to start off with, the client goes to the server going, hey, I'm getting ready to start off in this zone. I'm at this location. And then the client starts getting streamed information from the server, and it starts building its own database. So while you start off with almost no information at the beginning, it starts loading in based off of what parts of the world you're exploring. So theoretically, if you were so inclined that you visited every single part of the world, hit every single patch, by the end of it, you could have the database that is the same size as the server. But we also need to have a revision check or a version check. So the patch that is on the server, because it is dynamic and can be changed at any point in time, every time you get ready to load in that patch, the client has to do a check to the server, go, hey, do I have the right version? If I do, go ahead and load my cache version. If I don't, I need to get the new information down from the server, update your local copy so then you can get into the world. Let's see, so whether or not, like I said, whether or not we save the 3 different level details all in the same file or different files, that should be straightforward. As far as the system, we just put a couple extra lines of code if we need multiple files. The trickier part of it is going to be, again, when you're editing the terrain and you're painting something, because we're only going to set it up so you can paint on the high resolution information. So you're painting on the 2-meter information, and then that needs to propagate down to the 100-meter and then down to the 200-meter resolutions. So we're going to have code in place to be able to apply your changes and roll those back as things are modified.
We also had the question, I don't get the point of opening a full detailed patch file just to sample one vertex.
Exactly, which is kind of my point with looking at using a 1 file per patch. If you use a 1 file per patch, there's no way around opening up that whole patch file to get access to it. Even if it's random access, you're going to have to open up that file to read that one vertex and then close that file so you can go on to the next one. Now, if you're talking about reading in all of the vertices in, that would be if you did something like compressed all the vertex data inside of that file for size. So if you've compressed everything, and which is something we'll still have to look at because we need to stream this stuff from a server down to the client. So we don't want to stream this in its raw format. We're going to want to package it as small as we can, download it, and then save it in its uncompressed state locally so we can access it a vertex at a time. If we were to compress that record inside of it, we'd have to uncompress it to get the information for a single vertex.
Okay, Nelson just...
Hey,
yeah, go ahead, Nelson.
can you guys hear me? People are saying that.
Yeah, when you...
I'm not making any noise right now.
No, I know. I think it's something between your connection there and here. It's like Gavin says, it's digital clipping. It's. I thought it was Lee at first, but then I realized it was coming from you. But go ahead. Don't worry about it because it's just what we have to work with. Nelson, go ahead and jump in because I know there were some things you wanted to say and ask.
Yeah, okay, so imagine we're doing the single file format, and you said that you wanted random access for each patch, but then each patch will be compressed. And there's two things that I really don't like about that. The first one is if you want to load multiple patches at the same time, you wouldn't be able to allocate an array and use some sort of binary file reader and populate the structures directly, which would be potentially a very large performance hit because you're going to have to be checking each individual size and have manual serialization code rather than just overriding the memory directly with what you find in the file. And then in addition to that, it comes up to what Xavier was saying earlier, because you're still going to have to read the entire patch if you want a single vertice. If it were uncompressed, you would have random access to that vertice if you need to have it.
Yeah, that's what I just said. When I was talking about compression, I'm talking in a single file. Compression would be record-based. A record would be a patch of information.
But
now,
even in that scenario,
right? But the fact is just because we're compressing, if a record doesn't necessarily mean all of the patches information in its entirety. We can actually set up multiple records inside of this format for different parts of the patch. So you could have a record that is just the height information and just the offset information that is uncompressed, while we could compress the splat information for that same patch. The only time we need the splat information is when that entire patch is loaded into memory and it's getting sent to the video card, because we only send an entire patch to the video card. We're not sending in subselections of the vertices into the video card. So what we could do is we could query the vertices or vertices individually because they are in uncompressed format, but as a patch gets loaded and it's in its entirety, then we could download the compressed splat information and take that, uncompress it, and put it into memory where we need it. So by making the file format flexible, where we can set up our information into arrays and then choose whether or not that array, which is a record, is compressed or not compressed, we get the best of both worlds. We still have the ability to get down to the height information of a vertex with random access without having to read in all 2,601 pieces of information, while we could load in an individual splat in a compressed format with a minimum amount of information.
Okay. Then, however, if you want to, are you envisioning these records being sequential in some sort of order?
No, not at all. That's where I was looking at having it with the initial test that I did with the single file system. That's why there was a separate file that was just the index. The index is basically what the record is. It's got some sort of name to identify what type of record it is, and its position in the world, how big it is, where it starts in the data file. So you could sit there and the index would go, all right, I need the height map information for patch 1010. And it'd go, okay, that offset in the data file is this. It's this long, and this is its checksum. Go get it. And then go, oh, I need the splat information for the same patch. Oh, that is held over here, which could be, right next to it, or it could be at the very end of the file or at the very beginning. It could be anywhere inside the data file. It doesn't matter. As long as the index is accurate, then the offset offset starting position of that record is all that matters for the system to be able to read it in, and it needs to have a flag of knowing whether or not it's compressed or uncompressed, because the checksums that I would do would have to be based off of its state, and would have to have a compressed checksum, and I haven't figured out how to handle both yet. I haven't played with it, but you'd want to be able to check the file if the compressed file is corrupted, but you also want to have a checksum so you can determine once it's been uncompressed if it's still correct.
Right. And then are you planning on ordering the index at all? And then you said it was only 80 megs. That's something you can easily stuff in memory.
Yeah, well, that is if for 80 megs is 640,000 entries that are consistent. Once you start breaking things up into individual records, like you've got the height information in one record, the offset in another, splats in yet another, and you start segmenting it, your index could grow, and so it's not a fixed size every single time. But I would see the index being indexed and as long and sorted in an order based on the patch order in some sort, and then it have to be able to reorder itself, because if for some reason the index got too large to save in the memory, then we could save, every 10,000th entry, and then we could do a binary search through the index to find the right index to look up inside of it.
But you're talking about records and how there'll be multiple types of records. Wouldn't it make a little bit more sense to call a record all of the information and then just as part of the record, after the uncompressed data, that's the compressed data. So after the, how many bytes would that be? That would be 4 times 3, that would be 12 bytes for a float 3, and that's what you want to be uncompressed. And then after that directly is going to be your compressed value. At that point, your index could potentially get smaller because you don't need to have a pointer to 3 records per patch or 2 records per patch. Does that make sense?
I think so. You're talking about if you indexed everything based off of your uncompressed information, and then once you compress it, its index spot would stay the same, but you would fill the rest of it with dead information and just rely on the size of the compressed file to get to the end of it?
No, maybe.
All right. Also, just before it gets too much further up, how do you say that? Xaverix?
I think it's just Xavier K. But.
Xavier K? That'll work. It says, but I'm not sure. But if you have like 100 players running around accessing the same file at 81 places for each player, that's not going to get a little tricky?
We're not accessing, you don't have 100 players accessing the same file. You've got 100 players all accessing their local cached information on their machine. So the likelihood of all 100 players hitting the world server to request and stream in the information all at the exact same time for the same information is going to be fairly limited, which is why we're going to cache it out locally on the machine. So what ends up happening is the interest system is going to look ahead and try to intelligently guess where you're headed based on your current trends and position. And then it goes, okay, do I have this information? Okay, yeah, I do. Is it accurate? Yes, it is. Okay, continue. And then the moment it's going, you're headed north, up, you're getting into an area where I don't have any information. So then it sends a request to the server to stream you those patches of information ahead of time. So it calculates ahead of time that you're going to need this stuff before you even get there. So if there's a backlog, then you're still not going to have that, worry about that information for several seconds to a minute or so. So it gives the server enough time to queue you up to make sure that you get the information you need before you need it. And then once you've got that information, if you decide to run south again, then come back north, you've already got the information on your local machine.
You might have mentioned this, but how
Xavier
exactly?
says he was talking about server side.
Server side is kind of neat because server side we don't have Unity running for the world. This is going to probably be all in C# running in multi-threaded environment on a multi-core server, so it will be able to handle it. The limitation isn't going to be so much what the server can handle with the file. It'll be more our bandwidth restriction of how many patches we can stream to different clients at a single time. At least that's what I'm thinking.
How are you planning on handling? You might have already mentioned this, but for not hitting the server a billion times and having to get all the data, players are going to have to be informed if any patch that they have loaded is invalidated.
Right, and that gets into the interest management system of figuring out what they've got currently loaded and what they need to get loaded. And Jason's had some experiments with how to deal with that. So I don't know if they're going to be querying the server or if the server's going to be notifying it because you happen to have patches in your interest system that it needs the server to let them know if things are happening.
Anything that the client is subscribed to in an interest management system, the server is going to notify the client of anything it needs to notify the client of. Let's see if you have bandwidth limitation, server, couldn't you spread the data from client to client?
That's almost starting to talk like torrent type technology or like Skype, and that can get tricky because then you have the potential of somebody messing around with their data.
DMJ says it all though right there. Mistrust anything a client tells another client. I have a better one.
Exactly.
Distrust anything that has the word client attached to it, period.
Yeah.
Enrico, just to add to what Xavier asked, will that work if 100 players looks at, let's say, Jason, while he is sculpting the terrain, and get affected by the new heights. Let me throw this out real quick because anytime that they're talking about sculpting, because I saw some questions a little bit earlier that did not get answered in regards to terrain being sculpting at game time. And this is just some of the ideas that I've played around with, but it's not something that's a for sure. Obviously, when we have artists working in a zone or in an area within a zone, because the zones are so darn huge, we're not talking about hundreds of artists. At game time, what I'm picturing is if we are truly able to deliver a massive, massive world, it would be cool, especially if the game was free to play and there was some sort of, we later on we all got into microtransactions or something to have the game pay for servers and bandwidth or whatever. But if the game was free and anybody could just come into it, in the game you earn whatever kind of currency you could earn. It would be really cool if, NATO said it spot on. It's almost exactly what I said in the past, which is terraforming underway, do not enter. Basically, if you're able to pay for a piece of land that you can construct on, you pay for it. That would occur on your computer. So as you're sculpting and putting things together, the system, the client would know that this area is yours to sculpt. You're doing what you're doing, but people aren't seeing that. Rather, as NATO said, some sort of terraforming underway or something that prevents that area from being traveled into, or the area just doesn't even see a change or anything. People just can continue running through it. They don't know that you're working on anything.
Like an instance.
Yeah, like an instance. But because when somebody is done, they're going to have to submit it to an approval board. Because, come on, guys, we know how players are, and the last thing we need is a gigantic penis being modeled right in the middle of someone's land and them saying, "Ha, that's my tower. Suck it." So the bottom line is it's got to be approved, and then once approved, then that land could reshape to whatever they whatever it was that got approved. It seems like Go ahead, Lee. Go ahead. No.
I was going to say we could even do it game mechanic wise because we do have both sci-fi and fantasy available to us. There's nothing to say that we couldn't put up some energy field post that cordons off a section of patches for somebody, and like Jason says, you walk up to it, it says terraforming underway, and you block people out from going inside of that whole area, so they know, hey, something's going on in here.
Now, DMJ brings up a good point, and that is, said that could be tricky though, because adjacent patches would need to maintain edge continuity. Absolutely.
Smooth brush works great.
Absolutely.
Just a buffer, like a buffer that's being blocked off that the person editing can't edit, and that buffer is then calculated based off of what the person edits and the surrounding terrain.
So it's real nice with us being able to say, all right, you want to buy some land, go talk to this real estate person. And this real estate person says, here, let me show you what we have available and at what costs. Of course, we have decided what could be sold, and that those areas we could easily keep them away from patch edges, etc. We would have that ability ourselves.
Well, you could also set it up, you own this land, but then you put buffers between each sellable plot. So there's a one patch border around every plot.
Isn't that what I just said?
Yeah.
Is it? Okay, cool.
Did anyone listen to me?
No, I don't think so, Nelson.
really.
I'm sorry, man.
I do. I try.
I try, but you get me so depressed.
Yeah, exactly.
Well, I was saying people talking about vertices. I was talking about an entire patch.
Yeah, see, Justin just said, great idea, Lee.
Yeah, whatever. I'm about to depress you more because I think you guys are not, or have a slight oversight, I guess, because whenever a client moves into an area, they're always going to have to ask the server when the last time that patch changed. Always. There's no other way around it. I mean, you can't, unless you're willing to, this is ridiculous, but unless you're willing to keep a server-side map of every single player and what version of each patch they have, every player is going to have to request the server, has any of the patches that I'm about to load changed? And if they haven't, no, it can still use its cache. It doesn't need to reload anything.
Well, here's the cool thing. With the size of our patches, even the high resolution patch is 100 meters across. It's still going to take you almost a minute to cross that. And that one request to the server is nothing compared to the 10 to 20 to 30 motion updates that we're sending back and forth for each client to the server. So
No, sure, but my point is you're going to have to do a lookup against 800, 2 billion, however many freaking patches you have in this game. You're going to have to do a lookup and compare it to a timestamp.
But it's still all... See, you can put an update into the index, so it doesn't even have to hit the data file to get that. The update information can be in the index or saved off into another structure that keeps that separate, so you just do a single lookup. I'm looking at patch 1010. When was the last time it was updated? That matches mine. I'm good to go. Go on in.
Yeah, and that's more or less what I was going to suggest, but you just hadn't brought it up before.
And real quick, Enrico says, Jason, is this a gameplay limitation you want or a technical limitation you need? Do you know what he means? Gameplay limitation. If you could give me a little bit more to go on.
What is this?
That would be fantastic. And Photon says, and Lee, this will be for you as you've been, plotting out math and figuring how many bytes get transferred to the client for each patch?
Each patch, currently, if there's 32 levels of information, each with 4 bytes, it's 128 bytes of vertex for 326K a patch. That's for the full loaded information. Just the height information works out to be just under 10K, or right around 10K, or 10 to 20.
The client's not going to need all the swatches. They're just going to need the ones that are required for rendering.
Yeah.
And I'm just saying, if you store it compressed on the server in order for it to gain the optimization by not sending useless data, it's going to have to uncompress it.
Well, the problem
on the
with
server side and recompress it.
Well, see, the thing is, even like you were saying, the problem with saving it compressed server side, we don't want to save it compressed. We want to save it uncompressed, because every time you compress and decompress, we're going to lose information and we're going to corrupt it. So if it's saved uncompressed, we modify it there, we compress it for transmission and uncompress it at reception and deal with it there. So the only compression is going through the transmission pipe. So
Okay, well, that was a misunderstanding then. I thought you were, because I thought the whole thing about the index file having to point to data structure, or the whole multiple records thing, was because some records on the data, or on the database, I'm using finger quotes right here, might be compressed. But now you're
well, they'd be compressed for storage, but on the local client side. But this is, like, again, this is all theoretical stuff that I'm throwing around in my head. The stuff that's going to be edited all the time, just like a JPEG, you don't want to be recompressing the same file over and over. Eventually, you end up with a noisy mess. So with the height information that's always going to be edited, we don't want to be compressing and uncompressing that back and forth, where we end up with information like the flags to control what is a passable area of the terrain, where that's a single bit. Yeah, we can compress and uncompress that all day long. That's not going to be an issue. Flags of what vertices are visible or not for cutting holes in the terrain. That type of stuff can be compressed. Anything that's going to be edited and modified frequently cannot be compressed, or anything that we need to access with a random access seek, like the height of any single vertex. We wouldn't want to compress that. So it's going to be a lot of trial and error in figuring out what we can compress, what we can't compress, and get the feel for it. But if we design a data system that's flexible enough to handle any record being compressed or not compressed, then as we go forward, we have the ability of going, well, compressing that was a bad idea. Okay, let's start saving that uncompressed. Or going, we never changed that one. Let's go ahead and compress that part of the record.
Okay, hang on one second. Just before we get too far away, Enrico came back and just said about the sculpting and the terraforming that is not real time like with Minecraft. It's just so organic control is just so much trickier. Lee, you wanna throw in?
Okay, you lost me on that one. What?
Yeah, he's talking about how we were talking about them doing sculpting on their own computer, and then the changes get submitted, approved, and deployed. Versus, why can't they do it in real time to see the changes? Well, first of all, you wouldn't want them to do it in real time because, again, somebody who's going to go out and paint a penis. That's the very first person who's going to paint. I guarantee you.
Or some really nice words scrolled across their terrain.
Yeah, exactly.
Visible from space.
Yep. But then there's also tricky issues.
Like if somebody's standing on that patch of terrain while you paint it?
Yeah, there's definitely some...
Well, a lot of it is speed-wise. I mean, once you start getting into the sculpting and looking at how that's done, the recalculation of all the heights is intensive as it is. But if you wanted to be able to, let's say we did go, hey, we want this to be real-time painting all the way across the network from one client through the server down to the next client. You end up having to get to the point that every update you have to package any changes up, send that to the server. The server's got to write it to its database, and then send the notification to any other client that has subscribed to that patch. That gets a lot of network traffic going back and forth.
Like I said, very too tricky. I mean, we're going to have the real-time painting, but it's just going to be for a group of artists that are working together, not for potential hundreds or thousands of people being in an area.
And that could be peer-to-peer.
You're talking about modified
between artists. Between artists,
yeah, absolutely.
And then once you guys all agree to it, well, all the changes get streamed to the server, and once it gets approved, then we can submit the changes and commit them, and then that's the only time that they become official, so to speak.
What's NATO saying? At the moment, we want a primary construction phase? Sorry, I didn't follow you, NATO, on that one. ignored me. Oh, but I don't want to ignore you. That's no fun.
Anyway, are you still answering questions?
I just wanted to get Enrico, since he had asked me directly a question before it had scrolled off. So go ahead and go back, guys. Actually, let's do this. I know some of you guys are tired and going to bed, and you know the good news is you'll be able to catch these videos tomorrow. And anyone who's getting bored, because I know not everyone that's joining us right now is into the tech speak and all, but this stuff is really important to us, and it's about to be super important here. It's going to be super important by this weekend, and that's like right around the corner. So let me go ahead, stop the video here because we're at an hour and 5 minutes. Gavin, you forgot to tell me. And go ahead and take a break for those of you that want to continue on with us. And for those of you that are watching the videos, again, if this stuff doesn't interest you, that's the beautiful thing about videos. You can just simply skip them or just use the old slider button and drag through. But let's go ahead and take a break. If someone needs to grab coffee, use the bathroom, I'll save this video out. We'll get going in 5 minutes. Thanks a lot, guys, and we'll be right back.